Alrighty, so here is 7.2 in Hawks. And we'll just get started right away with number 1. These problems are a little longer, so I do have to write them, some of them anyway. So in this particular problem, the population declines, and here's the function that they give you. P of t equals 596,000 times e to the negative 0.022 t. T is the years. And the question is, how many people after 12 years? Okay, and so this one's a very straightforward plug and chug. So in this case, t is equal to 12. I'm going to take the function that they give me. I'm going to replace this t with the number 12, and I'm going to type it in. So I'm going to have p of 12 equals 596,000 e to negative 0.022 times 12. Now, when you're typing this into the calculator, please be careful and make sure that e is the only thing being raised up. Okay, so just be cautious. So when you type this in and you calculate it, you should get p of 12 to equal 457,712. And I believe the problem in Hawks states to round to the nearest person. And so when I do that, here's my answer. And now I'm done. Number 1, done. All right, number 2. Okay, so we're going to be dealing with inflation. And we are going to be given a function. It's c of t equals c sub 0 times 1 plus r to the t. And in this particular problem, it's going to tell us that a bike costs $28,700 now. With inflation, how much will it cost? So how much money will it cost in 5 years? So that's what I'm trying to figure out. So let's write down what I know. Oh, hold on, it's not 5 years, it's 15 years, sorry. So let's list the variables that I know. Well, I know that t is 15 years. I know that the interest rate is going to be given to you in the problem. I guess I should stick this up here. R is 1.5%, but we know that when we list it out, it's going to have to be listed out as 0.15 because we can't put a percent into the calculator, so to speak. How much does it cost now? The present cost, 28700. And what I'm trying to find is how much it will cost. And so I'm trying to find C of t. So in this case, instead of putting a t there, though, instead of putting a t right there, I'm going to put C of 15 since I actually have a time. So let me get that t out of there and let's put a 15 there instead. So C of 15. And so I'm going to take the function that they give me and I'm going to write in everything that I know. And so this will be C of 15 equals 28700, parenthesis 1 plus the rate, which is 0.015, raised to the t, which is 15. And since all of these are just numbers, you get to type this all the way in your calculator. Type in calculator. And again, just be cautious, okay? Make sure you take your time and go slow so that you don't miss any numbers. And so when you type it all in, you're going to get, since we're talking about money, put your dollar sign. So 35881.66. So $35,881.66 is how much it will cost in 15 years. All right, done with number 2. Okay, so number 3 is another inflation problem. So we're going to be using the same inflation formula. C of t equals C sub 0 times 1 plus the rate to the time t. Okay, so now we're going to say that a bike currently sells for $34,810. It did sell, so it sold for $23,200 5 years ago. And so what we are trying to do, we are trying to find what's the inflation rate. That's what we're trying to figure out. How much is the inflation rate rather? All right, let's list what we know. We know T is 5, takes 5 years. R is what we're trying to find, so we'll put a question mark. We know that the bike currently costs $34,810, and we know that its initial price, C sub 0, is $23,200. And so now all I'm going to do is take the values that I'm given, plug them into the formula or to the function, and solve for the rate, which is what I don't know. So I will have 34810 equals the initial value, 23200, parenthesis 1 plus R, because I don't know that, and then the T is 5. And so now all I'm trying to do is get R by itself. And so the first thing I'm going to do is divide both sides by 23,200. And when I do that, on the left-hand side, that's going to turn into 1.5. On the right-hand side, the 23,200s cancel, of course, leaving me with 1 plus R to the 5th. Now, in order for me to get rid of this 5th, I'm going to have to take the 5th root of both sides. So the 5th root and the 5th are going to cancel. So I'm going to have the 5th root of 1.5 equals 1 plus R. Well, now I got a minus 1 from both sides. Now I got to be careful here because the minus 1 is not subtracting from the actual root. It's just a subtract 1 outside the square root symbol. And that equals R. And so now you're going to type into your calculator the 5th root of 1.5. Then you're going to have to arrow out. And then you're going to do a minus 1. And when you do that, you're going to get R equals approximately, so let's turn this into approximation, 0.0845. But we know that our R value, which is the interest rate, has to be in the form of a percent. And so we take our decimal point, we scooch it over 2 places, and we say that R is 8.45%. And so the inflation rate for this particular problem is 8.45%. Now we're done. Number 3, done. Okay, number 4. So this is going to be a compounding problem, and it says that you invest $5,300. Okay, your interest rate is 4.5%. This particular bank or whatever is going to compound this interest continuously. And the question is, how much money do you have after 5 years? Okay, and so we're going to go through this and we're going to list out everything we know. Well, the first sentence says that you invest $5,300. So that's P. That's your initial investment, $5,300. The interest rate is 4.5%, so R is going to equal 0.045. It goes on to tell us it's going to take 5 years, so T is 5. And since it says compounding continuously, we're going to use the PE to the RT formula. Okay, so this is the formula that we're going to use. And so in this case, we don't have an end value, and we're going to raise it to the RT. So we're going to do a quick second, or take a quick second here to multiply the R and the T together. So we just have one number. And so here we go. We're going to say that A of 5, in this case, because remember we're putting a 5 in there, equals, whoops, not P, oh my goodness, equals 5,300 times E, raise it up to the 0.225. And all of this gets typed in. Okay, and remember, the letter E is just a button on the calculator. Okay, it's nothing crazy that you have to memorize. So when you type this in and calculate it, you should get, and since we're talking about money, we're going to put a dollar sign. You should get 6637 rounded off to 2 decimal points, 0.31. So the answer is $6,637.31. Done. So that's how much money you'll have after 5 years. Okay, next, number 5. You have a lot of money because you're investing a lot. So you invest $7,800 and your interest rate is 3.6%. It is compounded semi-annually. Okay, and the question is how much money, whoa, let me back up. I'm getting out of control. How much money do you have after 6 years? Okay, well, this one's similar-ish to the last one. We got to go through and we got to read. So the first number, 7,800, that's my investment, so that's P. The rate is 3.6%, so I write it as a decimal, 0.036. Ooh, compound semi-annually. That tells me two things. It tells me that my end value is 2, and it tells me that I'm going to use the formula, the compound interest formula, which looks like this. And so I'm reading, how much money do I have T? So T is 6 years. And so now I have a bunch of information, and I plug all my information into my formula, and I see what I get. So I'm going to say that A of 6 equals P 7,800, parenthesis, 1 plus the rate, 0.036, over the end value of 2. Oops, we got to go back. We forgot to determine what NT was. We just multiply these together, and we get NT is 12. And so we have 7,800, parenthesis, 1 plus the rate, 0.036 divided by 2, raised to the 12th. And so again, you're going to be able to type this in. And when you type that in, we're going to round it off to the nearest 2 decimal points, just like we would if it was actual money. And so we're going to get $9,662.02. And that's it. I'm done. All right, now, number 6. We're still working on banking problems, okay? So here's the problem. You can invest. You have some money to invest. You have $2,400 to invest, okay? I need to know which of these options that I'm about to write, which is the better deal, right? Which gives you the most money? That's the question, essentially. And so here we go. So we're going to have bank 1, and over here we're going to have bank 2. And so bank 1, let's write a few things down first. Both instances, you're using the same investment, $2,400. Both instances, the same amount of time will pass. In this case, 3.4 years. Now, on bank number 1, the rate that they're going to give you is going to be 0.0257, and it's going to compound semi-annually, so the end value will be 2. And we're going to go ahead and find our NT. And when I do that, I'm going to get 6.8. Now, over here on bank 2, my investment is $2,400. My time is 3.4 years. They have a different interest rate. It's going to be 0.0243, and it's going to be compounded daily, which means N is 365. And so when I find my NT, when I do that, I'm going to get a bigger number, 1241. All right, so now the idea behind this problem is to calculate both of these and make a decision. Which one of these would you want to invest your money into? Which would give you the greater return? So let's do bank 1 first. So we're going to have $2,400 times 1 plus the rate, 0.0257 over the N, raised to the 6.8. Now again, this is just straight calculator work. So when you type this in, you're going to get 261769. Okay, so if you put your $2,400 into bank 1, after 3.4 years, you're going to get $2,617.69 back. Now let's do the same exact thing for bank 2. Let's calculate it and see what we get. So we're putting in our $2,400, 1 plus our different rate, so be careful of your rates, 0.0243 divided by the N of 365, and that whole thing is raised to the 1,241st power. And so again, this is strict calculator work. So you type all this in, and the number that produces back to you is $2,606.70. And so now you have two values, and what you're going to have to do is compare them. Obviously, if you're putting money in the bank, you want to get the most money back. And so which one's greater, 2,617 or 2,606? So what you're going to do is clearly you're going to mark this one. And then in Hawks, there's going to be the little symbols beside the banks, bank 1 and bank 2. You're going to click in bank 1. And now you're done. Now on Hawks, it's not asking you for this number, okay? But hear me when I say I am. So if I give you a question like this on the test or on a paper homework, I expect to see the work. I do not expect you to just click and hope for the best. Okay, so on we go. Number 7. Alrighty, so number 7. You hope to earn $700 interest from your investment of $35,000 in 2 years. Okay. If the bank that you're putting your money into compounds the interest annually, what is the interest rate that you need? What is the interest rate? Okay, so what we're trying to solve for here is R. So let's go through, read this again, write down everything we know. And so the value that you initially have to put in there is $35,000. So P is $35,000. T is 2 years. R is question mark, we don't know. And if you hope to earn $700, then what's going to have to happen is you're going to take that $700 and you're going to tack it onto this $35,000. And that's going to be your A of T. That's going to be your future value, how much you will have. So if you put all this in and you do get the 700, then your future value is $35,700. Now, it goes on to say that it's compounded annually. And so when we talk about compounding annually, it tells me two things. It tells me N is 1, and it also tells me that I have to use the compound interest formula. And so I'm going to go ahead and quickly multiply my N and T. And so when I do that, I just get the number 2. Okay, and so now I can take this information, I can put it into this formula, I can solve for the rate. So here we go. We're going to have A of T, which is going to be $35,700 equals P, which is 35,000, parenthesis 1 plus the rate, which is what we don't know, so just leave it as an R. The N value is a 1, and the NT is a 2. All right, so we have to remember that this 35,000 is not being raised up. So we're going to divide both sides by $35,000. On the left-hand side, when I do this division, this number that I get is 1.02. On the right-hand side, the $35,000, divides out, leaving me with 1 plus the rate. Now, since this is R over 1, instead of putting that, let's just say, you know what, R divided by 1 is just R. And that whole thing is still squared. All right, well, now I'm going to have to take the square root of both sides. So the square root and the square cancel, and that leaves me with the square root of 1.02 is equal to 1 plus R. Oh, now I got a minus 1 from both sides. So the square root of 1.02 minus 1 on the outside equals R. And so we're going to say that R is approximately, now again, you're just going to type this into your calculator. When you do that, you're going to get 0.00995. Now here's the thing. In Hawks, it's going to tell you to round to 2 decimal places. Okay, and so when we do this, this is going to be my right answer, so to speak, but I got to round it, okay? So we can't type that in because we're not done. So we're going to take our decimal spot point and we're going to move it over 2 places, and that's going to give me 0.995. But again, since it says 2 decimal places, I can't have these 3 numbers. So if I have 0.995 and I round it, well, if I'm trying to round to 2 decimal places, that's right here. If I look at 9, if I find 9 and I look over 1, find a place, look next door, 5 or higher, add 1 more, this whole entire bit is going to round up, and so R is going to equal 1.00%. Okay, now when you're doing this in Hawks, you're probably going to get this answer, and you're going to be like, oh, great. And then you're going to round it to this, you're going to say, oh, great. And you can type it in, and Hawks is going to say no. So you're going to have to pay very close attention to what it's asking you. Sometimes this might be a 3 or a 4 or a 5 or 6, I don't know. But in this particular problem, it was a 2. So my final answer that I have to type into Hawks for this one is 1%. Done. Okay, number 8. You invest $8,200 at 4.4%. That's your interest rate. This is going to be compounded daily. The question is, how much money do you have after 3 years? Okay, so we just read through this and we write everything we know. So the first one is you invest 8,200. Well, that's P, 8,200. At 4.4%, that's the rate. So we turn it into decimal, 0.044. Compounded daily, that tells me that N is 365. It also tells me which formula I'm picking. I'm picking the compound interest formula. And then it goes on to ask me or tell me 3 years. So t is 3. So here's all the information I need. Let's go ahead and get my NT. So 365 times 3 is 1095. Okay, so I'm ready to roll. And so I'm going to say 8200 equals, whoops, no, I'm kidding, not equals, so sorry. 8200 times 1 plus the rate, so 0.044, over the n value, 365, raised to the 1095. And again, this is just to type in the problem. So this was what, A of 3, yeah. And so when we type all this in, and you round it off to the nearest 2 decimal points, because remember, this is money, we'll toss a money sign in front of that. And when we type this in, we're going to get $9,357.01. And this is my final answer. That's how much money I will have in that particular account after the 3 years. Done. All right, number 9. Okay, so you're scientists again, and this is going to be one of the population growth problems. So you start with 286 bacteria. Okay, and you have them in your little petri dish, and you're feeding them, and you're watering them, all that jazz. And the population in this particular problem, the population will quadruple every 13 minutes. Okay. Now there are 2 parts to this. There's part A and there's part B. And what we are trying to do, okay, well, first of all, let's back up for a second. Since we're talking about population growth, that tells me the formula I'm using is P of T equals P sub 0 A to the T. Okay, this is the formula that I got to use. And we're going to have to recognize that so we can look at our formula sheet. Now, the first thing that we are trying to do, part A, is we are trying to write the function that looks like this, but is very specific to this problem. And so what we need to do is we need to find A, and we need to write a function. That's part A. All right, so let's list everything we know. Well, the very first thing it tells me is that I start with 286 bacteria. So A sub 0, which is just my initial amount, that looks like a 6. A sub 0 is 286. Now, it goes on to tell me that it's going to quadruple every 13 minutes. So 13 minutes is the time. And after 13 minutes have passed, I have quadruple what I started with. And so since quadruple means 4, all I need to do is take 286 and multiply it by 4. And so that's going to give me this. That's going to give me, hold on a second, I accidentally put an A here. Should be a P. P sub 0. So we're going to say that P of 13 just means 13 minutes have passed. We're going to take our initial value and we're going to multiply it by 4. And when I do that, I'm going to get 1,144. And so I started with 286, okay, here. 13 minutes passed, and now I'm up to 1,144. Now, that's what I have to use to find my population growth rate. And so here's what we're going to do. Take everything we know and plug it into this formula. So we're going to say that P of T in this case is 1144, and that's going to be equal to 286, because that's what I started with, times A, and then the time that has elapsed is 13. And this first piece, all I'm trying to do is solve for A. And then I'll write the function. And so I'm going to divide each side by 286. And when I do 1144 divided by 286, that gives me the number 4. And that's going to be equal to A to the 13th. And so I'm going to have to take the 13th root of both sides. And so I'm going to get that the 13th root of 4 equals A. And so when I round this, I think in Hawks it told me to round to 3 decimal points. It's going to tell you. Okay, so you won't have to guess. It'll tell you. And so I'm going to round to 3 decimal points. I'm going to get A is approximately 1.113. Okay, so I found A, check. Now I have to write the function that is specific to this problem. And in fact, I'm going to do that over here. So I'm going to erase B for just a second. So we found A, wonderful. And so now we are going to put it here and we're going to write our function. So we're going to say that P of T equals P sub 0. Actually, back it up. We know P sub 0, don't we? It's 286. We just found A to be 1.113, and then we don't know how much time has elapsed. And so this is going to be the formula. I no longer need this guy, right? I don't need to look at him anymore. This right here is going to be the formula very specific to this particular problem. Now, letter B is going to come in here, so we're done with letter A. Letter B is going to say, okay, well, go ahead and use the formula that we just have up here to find the population after 2 hours has passed. Okay, well, we know that T is 2 hours. Now, here's where we have to be super duper careful. If we go back to the very first beginning of our problem, it's not giving me T in hours. It's giving me T in minutes. So I'm going to have to turn this hours into minutes. And so my question is, how many minutes are in 2 hours? Well, there's 120 minutes. Okay, so I don't care, and I can't use this. Okay, I can't mix times, so to speak. And so I'm going to take this formula and I'm going to plug this T into it, and I'm going to calculate, and that's going to tell me how many bacteria I have after 2 hours has passed. Okay, so we're going to say P of 120 equals 286 times 1.113 to the 120th. And then again, you're just going to type this problem in as it is. Okay, all of this gets typed right in. And when you do that, you're going to get a big number. And also, it says in Hawks to go ahead and round this to the nearest whole number. And so we're going to have 108,588,980. And so the answer to this problem is 108,588,980 bacteria. And there we have it from start to finish. We're done. All right, next, number 10. Number 10, sorry about that, I had a technical error. Okay, we are going to be given this function, and it's going to be C of t equals 0.03 parenthesis 1 minus e to the negative 0.2t. And this particular formula tells us the concentration of a certain drug in your bloodstream. And this problem wants to know how much of the drug is left in your bloodstream after 9 minutes. So this problem is going to be super easy, okay? They give us a formula. We don't have to try to come up with anything at all. They give us a time. So what we're going to do is we're going to say, oh, well, t is just 9 minutes. And we're going to take this function, c of t, and we're going to say, all right, well, after 9 minutes have passed, I have 0.03 times parenthesis 1 minus e to the negative 0.2 times 9. And again, when you type in this in, I need you to be very cautious about the way that you type this in, okay, which is why I'm showing you the answers and making sure that you can get that. So you're going to type this in as it is. And when you do that, you're going to get 0.025. And that's it. We're done. Right? There's 0.025, grams maybe. I'm not sure. I didn't write down the unit. But this is the answer, 0.025. Done. All right, now, number 11. We're almost done. Just a few more. But number 11 is a half-life problem, okay? So this one says the half-life of chromium 49 is 42.3 minutes, okay? So step A, letter A, we need to determine the A and write the function. Okay, so what we have to do is we have to look back at our problem. And since this is a half-life problem, we're talking about decay. And so we are going to be using this function, A of t equals A sub 0 equals A sub 0, A to the t. And so this is the function that we're using, okay? And so we have to find A first, and then we have to use our specific information to rewrite this function. Okay, so let's find A first. So let's talk about the half-life. We know that the half-life T is 42.3 minutes, okay? And so we also know that this A sub T is going to be half of our original amount. So A sub T, check, half of our original amount equals our original amount times A. Well, how much time has passed? Well, 42.3 minutes. So here's the first part of me trying to solve for A. Then I'm going to divide both sides by a sub 0, and in each case, they cancel each other out. They divide out. So I'm left with 1/2 equals a to the 42.3. Now I know this seems ridiculous to take the 42.3 root of something, but that's exactly what we're going to do. So 42.3, 42.3. Then of course on the right-hand side, the 42.3 root being raised to the 42.3 cancels. So I'm left with a equals the 42.3 root of 1/2. And when I calculate that, that's going to give me approximately 0.983747. And again, in HAWX, it's going to tell you how many decimal places. In this particular instance, it asks you to round it to 6 decimal places. So here's my A value. That's this little guy right here. And so now I'm ready to actually rewrite the equation. Okay, so let's take a look at letter B. Let's take a look at letter B. So let me go ahead and do this. So this is part B. And we got A to equal 0.983747. And the function that I know I need to use is a sub t equals a sub 0 a to the t. We'll do B and C on the same page so that you can see them, okay? And so letter B wants me to know how much of this element of a 4-gram sample is left after 5 minutes. Okay, well, we have A. We know that T is 5. We have an A sub 0, which in this case is 4. We have everything that we need to plug into this guy. So we're going to say, all right, A sub 5 equals the A sub 0, which in this case is 4, times the A value that we calculated in the last step, raised to the number 5. And this is what I type in. And when I do that, I'm going to get that A of 5 equals 3.685. And what are we talking about? We're talking about grams left. But this is the number that I'm concerned with. This is the number that I'm going to type into HAWX. And again, it will tell you how many decimal points to round it to, so please make sure that you read. All right, letter C, we're still using the same information as we did up here, but this question says how many grams of a, and this time let's see, my goodness, I need to restart this. How much of a 4-gram sample, so just like the last one, is left after 69 minutes? Okay, well, same thing up here. We're going to say, well, we have our A value. In this case, the T value is a 69. We have everything we need. So we're going to say that A of 69 equals my initial value of 4 grams times the A value that I found in part A, in this case raised to the 69th. And this is what you type in. And so we're going to say that A to the 69th equals, we type all of this in, we hit enter, 1.291 grams. Okay, but again, when we're typing it in HAWX, which is what we're doing here, we're just going to type in this number. And that's it. There's my half-life problem. All right, 2 more problems to go. 13. You have $5,300 to invest. The interest rate is 5.9%, and it's going to be compounded continuously. Okay, the question is, how much money do you have after 5 years? All right, so we got to read through it. We got to list everything we know. So the first number is 5,300. That's how much money you have to invest. That is your p-value. The rate is 5.9%, but again, we have to write it as a decimal, so 0.059. The time, it says, is 5 years. Let's go ahead and say, oh, hey, it's compounding continuously. There's no n value. This is the problem where I have to use the PERT formula, right? A of t is equal to p times e to the rt. So let's go ahead and find our rt real quick. So we're going to take R, we're going to take T, we're going to multiply them together. We're going to get 0.295. And now we're ready. So we're going to say that A of 5 equals the p-value, 5,300. Remember, E is just a button on the calculator, but we're raising it to the 0.295. And so this is what you type in. And when you type that in, you hit enter. We're going to toss a dollar sign out in front because we're talking about money. And we're going to get $7,118.57. And now we're done. All right, last one, number 14. Luckily for you, no, I'm sorry, number 13. This is also a half-life problem, okay? So it's just another example. And it tells us that the half-life of radium-224 is 3.66 days. And letter A, we are supposed to find the A value, okay? And we'll write the equation later. Okay, so since we're talking about half-life, we're talking about decay. The function that we're going to use is A of t equals A sub 0 A to the t. And we know that A sub 0 is our initial value, A is the rate, t is the time. And so let's think about this. Well, if we start out with some of it, and after 3.66 days, we have half of it left. So we can say that half of our initial value is what's left after some time passes. So instead of rewriting this A of t, we're going to write 1/2 A sub 0, and that's going to equal just the rest of this. So A sub 0 A to the t. And the first step is now to get rid of A sub 0 by dividing both sides. But I got to back up for a second because I'm getting ahead of myself. I forgot. How much time did they tell us? 3.66 days. Okay, so not a t up there, but a 3.66. So I'm left with 1/2 equals A to the 3.66. And now I've got to take the 3.66th root. And so I'm left with A equals the 3.66th root of 1/2. And so when I type all of this in, again, I just type it into the calculator as you see it. And I'm rounding this again to the six decimal places, which again, Hawks will tell you. I get 827,468. That's my A value. And so eventually, I'm going to be given a initial value. I have my A value. They're going to tell me how much time has passed. So I'm ready to actually do a problem. Okay, so I can actually probably squeeze B right on here so that we can take a look at it while we're looking at the function itself. So here will be the part B. So the question is, you start with a 5-gram sample. How much is left after, it would help if I could spell, after 9 days. Okay, so that's the question. So in this case, A sub 0 is 5. That's how much I start with. T is 9, and we already found A right here. And so, well, all that's left to do is plug it into this equation. So A of 9, because that's how many days have passed, equals 5 times my rate of A, 827,468, raised to the 9th. And now I type this all in, and it's going to say in Hawks, round to so many decimal points in this, or decimal places. In this particular problem, it says 3. And so I type all of this in, and that's going to give me 0.909. And that's my answer. Simple as that. Now, letter C is going to be the same type of a problem. You're still going to start with 5 grams. But now I want to know, 5-gram sample. Now I want to know how much is left after 2 days. So the idea here is the same. A sub 0 is still 5. That's how much I'm starting with. T is now 2, though. Okay? And so we're going to say that A of 2 equals A sub 0, which in this case is 5, times my actual A value, which I found in step 1, 0.827468, and I'm going to raise that to the 2nd power. And so again, I go to my calculator, I type all of this in, and it still tells me to round to 3 decimal places. And so when I do, I get 3.424. And this number, I guess there's this number right here, this number is what I need to know. That's what I type into Hawks, and that's it. Now, I'm totally done with this section.